Mr. McMurray, and we're here doing the vector and resultants worksheet again because nothing says fun like doing it twice, right? All right, we had finished most of it, but we need to do a little bit more. And so, for example, if you look on here, we had filled in distance, average speed, displacement, but we'd left the last blank open, and we need to fill that up now, and that we're done. Okay, now you had drawn a thing that went all the way over here, but I believe it eventually ended up 1, 2, 3, 4, 5, 7, 1, 2, 3, about somewhere about here. Okay, I could be a little bit off, but we're going to say about there, and that's where it ended up. Now I know you have a bunch of going around, but that's where it ended up. Okay, so the first thing I want you to do is on all your drawings, I want you to go from your starting point and draw a line down here to your ending point. And if you remember right, that is called the, yes, that is called, that shows our displacement, and that is called, the arrow that shows that is our resultant. Okay, so you're basically drawing a resultant here. Now, hopefully you can line up a little better with this than I did with mine. Okay, because that's just the way it is. Okay, and we're using this new tool here, and it sometimes works pretty good, sometimes not. I missed it a little bit there, but draw a line. Now, you also can put an arrow at the end of it. That's okay. Show that you went this direction. You started here and you ended up here. Okay, so that is a resultant showing our displacement from where we started to where we ended up. Now, on the last worksheet, we just said that we went southwest, and that's true, but technically over here would be southwest, here would be southwest, here would be southwest, here would be southwest, here would be southwest. A whole bunch of different places here would still be considered southwest, even though they're not the same direction as this line. So what we really need to do is find a more specific way to measure this. Okay, and so we are going to do it with our protractor. Now, the first thing is we are always going to measure from the north-south, the east-west line. Okay, are we north of that? Are we south of that? Which one? Okay, and we'll explain why here in just a second. But, all right, now, so I'm always going to put my protractor on an east-west line. So for none of these will I lift my protractor up and do a sideways. Okay, I will never have my, on any of these, I'm not ever going to have it like facing this direction or facing this direction. Someone says, well, why not? Okay, well, here's the deal. We say southwest, which really means here's the west line. How much south of west are we? Okay, so really instead of southwest, we should say it's south of west. Okay, and we're going to measure how many degrees. If this is the west line coming out from where we started, then we're going to measure how many degrees south of that we are. So when we talk about southwest, we can say we're so many degrees south of west. Now, if we did it this way, all right, we lined up on the north-south line, then what we would really be measuring is how many degrees west of the south line are we? Okay. Now, just for the record, if you add that's saying how far west you are of the south line. Okay, this is going to get your number around 20 something. This is going to give you a number around 60 something. If you add those two numbers together, guess what? You get 90, because in this whole area between south and west is 90 degrees. Okay, but if you get the wrong one, 65 instead of 22, that's going to happen a lot this year. Okay, especially when we first start out. So make sure you're always measuring from east or from west. Now in this case, we went this direction, so it's going to be the south line. All right, I mean west line. Since we went this direction, that's west. Okay, so we're going to line up our protractor, put the hole right here on our starting spot, or the little crosshairs, either crosshairs or hole, whatever your protractor has right there on the starting spot. Okay, then we're going to measure how many degrees from west are there. Well, since I'm starting from this line, I start with 0, 10, 20, and I'm going to get 1, 2, about 23. Okay, mine may be in between 23 and 24. My line is so big and fat compared to my protractor, it's hard to tell exactly, but I'm going to say 23.5. Now, since each of these goes by 1, you need to put your answer to the tens place. So if it's exactly on something, like say it's exactly on 20 here, then you would put 20.0. If this were 23.0, I would do that, but it's actually, the line goes between 23 and 24, right in the middle. So I'm going to say this is 23.5, okay? And that's because that's where it is, okay? 23.5 degrees, okay? So that's what you're going to do. You're going to read that angle and put that number down here in the last blank. And since it's south of west, here's the west line, and it's south of that, it's 23 degrees south of, I want you to go ahead and put of in there, south of, all right, west. Okay? Now that works because this is, in fact, 23 degrees south of west. Okay? If you did it from west of south, it is 66 to 67. Well, if you put 67 and 23 together, you get complementary angles. I believe it's complementary. I think supplementary are 180. So that's going to be 90 degrees. Okay? So if you put 67 degrees south of west, well, 67 degrees is going to be down here somewhere. Okay, south of west. So make sure that you put the right degrees. So for each of your other drawings, draw a line from your straight to your other. You may have to turn it different directions. It's either going to be, if your line is on, if started here and you ended up over here somewhere, then it would be like south of east. Okay. On some of these other ones, you may have your protractor turned around this way, and you may be set up on the line. If it's over here, it's going to be north of the east line. If it's on this side, you're measuring this way, it would be north of the west line. So north of west, north of east, okay? So basically, if the measurement before you had southwest, it's going to be south of west. If it was northeast and you got it right, then it's going to be north of east, and so on, okay? So draw the line for each of them, and then measure the angles from where you started to where you ended up, and put those in the last blank. Once you get those filled in, then you can submit your document. All right, submit your CAMI document. The only blank that needs to be filled in on each of the 5 questions is just this last one, because you should have already done the other ones. Okay, and on the CAMI document, you should be able to click on it with text. Click on text on the side, and then click on it and just type in your answer. Just for the record, well, I don't know. On a MacBook, it's option K is the degree sign. If not, you can just put the word degree, or just put a little O superscript or something like that. Somehow try to make that little degree sign, but anyhow, that will work. So once you've done that, if you will submit those, then that will be it. That's a pretty easy day today. All right, and that will be it for the assignment. Now there is one other thing I would like for you to do, and let me type this in because I think it's going to be kind of hard to see otherwise. Okay, I would like to see you go to this web page, www.physical. No, not physical. Sorry, my bad. It's been a long day. All right, here we go. www.essential-physics.com. Okay, this is the textbook that we use for our thing. We have an online textbook. Okay, this is the website that will get you there. Once you get there, there may be a map that pops up, and you will click on state of Texas, and then there may be a word box that pops up again, and it'll say Texas, Texas Review, and something else. Click on Texas, so you're going to click on Texas twice, and then it will give you a place to enter a code, access code, and that's going to be 742-098-4543. Okay, and you will type in that, and then you will click on, right next to it, it'll have a thing, click on Student Edition. All right. Once you get there, if you will go to page 180, all right, there will be a little white box over on the side that says go to or something like that, or go to page. And if you put it in that box, if you click 180 and then click on it, it will take you to the internet. All right, and it'll take you to that page. So let me just walk you through that up here real quick. Since I've got a little bit of time here, let me just go and do that. Let me for my internet to come up. It's going to take a little while here. Get a new tab. All right, I am going to go to www. No, is this again? Okay. www. Essential physics.com. Okay. Let me get rid of this other stuff up here because you won't have all that stuff coming up. Okay, it'll take me to this web page, hopefully. I don't know why it's not going there. Okay, and it'll say click on your state, and I'm going to click on Texas. The little box comes up. I click on Texas again, and I will put in my code 742-098-4543. I think that's correct. Yes, okay. And then you click on Online Student Book. All right. And eventually it will load, and you should come to a home page like this. Go to page is over here. You just put in 180, and it will take you to a page like this. Talks about vector navigation and talks about the ErgoBot, which I'll be using, and we'll talk more about that later. You can't actually do it from home, but I would like you to play with the mazes a little bit. There's a little thing called physics here, and probably on Thursday I will have a recording and have you play around with some of this and practice with it. Okay? But for right now, I just want you to go there, click there, make sure you can get there, and so you'll be ready in the future. All right, that's it for today then. Don't forget to submit your vector and resultants worksheet with the last blank filled in for each answer. Have a great day. Or if it's too late for that, have the best day possible.